Graphing from vertex form. In this form, begin by identifying h and k. These are the coordinates of the vertex. Then complete the rest of the steps to graph the parabola. This form is the easiest form in which to see transformations. These are movements or changes from the parent function. Remember that the parent function is y equals x squared. If a constant is added or subtracted from that function, the function will graph up or down from the original parent function. If a number is added or subtracted inside the parentheses, then the parabola will move right or left. If the number at the beginning that's multiplied times x squared is not 1, then the parabola will stretch or dilate. If that number is negative, the parabola will reflect downwards. Here is an example. Begin by looking inside the parentheses. The opposite of whatever you see is h. Since we have -3, h is +3. Then look outside the parentheses. That stays the same. It's -8, so k is -8. The vertex is +3, -8. A is the number 2, which is positive. That means this parabola opens upwards. It has a minimum at y equals -8. The axis of symmetry is x equals 3. Graph the axis of symmetry and the vertex. To find the y-intercept, plug in x equals 0 and solve for y. Be careful of PEMDAS. The y-intercept is 0, 10. Graph the y-intercept and a point the same distance away on the other side. The domain, as always, is all real numbers. The range is y is greater than or equal to -8. For vertex form, we will label the transformations. Look at the vertex. It is right 3 units from the origin. It is also down 8 units from the origin. A is 2, so it is stretched or dilated by a factor of 2. The parabola faces upwards, so there is no reflection. Now we can use our pattern to find the rest of the points. 2 times 1 is 2, so over 1 and up 2. 2 times 4 is 8, so over 2 and up 8. 2 times 9 is 18, so over 3 and up 18, which are points we already have. Draw a smooth curve. We can always confirm this pattern by doing a table as well. Here is another example. In this case, h is -3 and k is 2. The vertex is -3, 2. A is +1, so the parabola opens upwards. It has a minimum at y equals 2. The axis of symmetry is x equals -3. Graph the axis of symmetry and the vertex. Find the y-intercept by plugging in x equals 0. The y-intercept is 0, 11. Graph the y-intercept and a point the same distance away. The domain is all real numbers. The range is y is greater than or equal to 2. To get the transformations, look at the vertex. The vertex is left 3 from the origin point and up 2 from the origin point. A is 1, so there is no stretching or dilation. And since A is positive, there is no reflection. The parabola opens upwards. Find the other points by using our pattern. Over 1 and up 1. 1 times 4 is 4. Over 2 and up 4. 1 times 9 is 9. Over 3 and up 9. Draw a smooth curve. Pause the video now and try the next one yourself. Now that you have tried it, check your work. The vertex is 1, -8. The parabola opens upwards because A is positive, so we have a minimum at y equals -8. The axis of symmetry is x equals 1. Plug in x equals 0 to find the y-intercept. The y-intercept is 0, -6. Domain is all real numbers. The range is y is greater than or equal to -8. The transformations are right 1, down 8, dilation by 2, and no reflection. The pattern for the other points is 2 times 1 equals 2 over 1 and up 2. 2 times 4 equals 8 over 2 and up 8. 2 times 9 equals 18 over 3 and up 18, which is off the graph. Draw a smooth curve. Pause the video again and try this one yourself. Now that you have tried it, check your work. H is -2, K is 9. The vertex is -2, 9. A is negative, so the parabola opens downwards with a maximum at y equals 9. The axis of symmetry is x equals -2. Graph the vertex and the axis of symmetry. Find the y-intercept by plugging 0 in for x. The y-intercept is 0, 7. The domain is all real numbers. The range is y is less than or equal to 9. The transformations are left 2, up 9. The dilation is shrinking by a factor of 1/2. A is -1/2, so this parabola opens downwards, so it is reflected. To find the other points, use our pattern. -1/2 times 1 is -1/2 over 1 and down 1/2. -1/2 times 4 is -2 over 2 and down 2. -1/2 times 9 is -4.5 over 3 and down 4.5. -1/2 times 16 is -8 over 4 and down 8. -1/2 times 25 is -12.5 over 5 and down 12.5. Draw a smooth curve. This parabola is missing the constant on the end. Add a 0 and proceed as usual. Pause here to try it yourself. Now that you have tried it, check your work. The vertex is 2, 0. A is positive, so this parabola has a minimum at y equals 0. The axis of symmetry is x equals 2. Graph the axis of symmetry and the vertex. Plug in 0 to find the y-intercept. The y-intercept is 0, 4. The domain is all real numbers. The range is y is greater than or equal to 0. The transformations are right, 2, and no other transformations. Use our pattern to find the other points. 1 times 1 is 1 over 1 and up 1. 1 times 4 is 4 over 2 and up 4. 1 times 9 is 9 over 3 and up 9. Draw a smooth curve. In this case, the parentheses is missing. You can replace the x squared with x minus 0 squared and put a plus 0 at the end. Now pause the video and proceed as usual. Now that you have tried it yourself, check your work. H and K are both 0. The vertex is at 0, 0. A is negative, so this parabola opens downwards. It has a maximum at y equals 0. The axis of symmetry is x equals 0. Graph the axis of symmetry and the vertex. The domain is all real numbers, and the range is y is less than or equal to 0. The transformations have no movement right or left and no movement up or down, since the vertex is at 0, 0. The graph is dilated, or stretched, by a factor of 3, and because A is negative, it opens downwards, so it is reflected. To find the other points, follow our pattern. -3 times 1 is -3, so over 1 and down 3. -3 times 4 is -12, so over 2 and down 12. Draw a smooth curve. In this case, once again, the parentheses is missing. Replace it with an x minus 0 squared and proceed. Pause the video here and try it yourself. Now that you have tried it, check your work. H is 0 and K is -11. The vertex is 0, -11. A is positive, so this parabola opens upwards. It has a minimum at y equals -11. The axis of symmetry is x equals 0. Plug in 0 for x to find the y-intercept. which is in fact the same as the vertex, 0, -11. The domain is all real numbers. The range is y is greater than or equal to -11. The transformations, there is only one, down 11. There is no other transformation. To find the other points, use our pattern. 1 times 1 is 1, over 1 and up 1. 1 times 4 is 4, over 2 and up 4. 1 times 9 is 9, over 3 and up 9. Draw a smooth curve. Please refer back to these notes as often as you need to complete your homework.